Okay, so I guess I will not repeat the highlights, but for anyone who are on the recording, please read the highlights for the two votes that has passed for and property name fixing stats and partition stats. Okay, any other highlights that people want to mention? Cool. Then let's jump to the discussion points. So the first one for REST capabilities, I think there are a lot of things going on in the REST capabilities. I think the ask I have is, can we have a actual improvement proposal written for that? Because there are many discussion points that are on the dev list, and I think at this point it deserves just a proper proposal for that. What are people's thoughts? Cool. And
So Edward isn't here, so
yeah.
we can reach out to him and ask if he can just pull together a quick summary of where things stand. I think based on what discussion happened last time, I think the only outstanding point people kind of are questioning is whether we should include table spec and view spec as capabilities that are versioned, as opposed to just allowing the commit endpoints to enforce that. And I don't know if other people were here that were part of that discussion. I think the question is just like, what value is there in putting the current or the supported table specification? Because we also have the tables capability, and that's versioned as well. And so do we want to include both? Anybody have any strong opinions about that?
I do. You should have strong opinions. I'm very much in favor of adding this at table-spec or whatever and view-spec, because what essentially is transferred to the server or received from the server is not a full table metadata with having a fixed version number, but also parts of these structures. And the server cannot assume that it fully understands it because there can be attributes that it doesn't know about. And if that happens in a requirements or updates structure, then what should the server do? Should it ignore the requirements thing? Should it maybe ignore the potential restriction that's been added at some point? So at that point, I think the behavior becomes quite ambitious, and it's not much work to now add table spec 1, 2 and view spec 1, because it can save a lot of headache down the road.
So I kind of disagree with that, and that's because we're overlapping two concepts, which is what is the REST representation and what is the table spec representation. And in the REST spec, we actually have a little bit that's combined, because what we're doing is we're representing a lot of the table metadata in the actual REST representation, but that would be versioned with the tables endpoint. So if something like what you were saying, Robert, was like, hey, there's a new property or a new field or something like that that gets introduced into the REST specification, that would actually be versioning the tables.
But we also include the snapshot object, and this is part of the table spec.
That is part of the table spec, but the spec portion of it can be handled by the catalog without having to represent it in the actual.
Yeah, go ahead.
And the concern that I have there is that even with a spec version, we know that there are implementations that don't fully support that spec version. So it's entirely up to the catalog to be able to just, hey, I reject a commit because even though I say that I support 2, I may not support a specific feature within 2. So we can't really.
True, but yeah, true. That's part of that specific version. But nothing prevents a client to send a v4 table spec snapshot object to a v1 to a REST server that only supports v1.
But we already have the table version in the request and response objects. So now we have So
Do
in
we
the
always?
metadata, I believe that's the case, right? Isn't that in
Yes,
the? Yeah, it's in there. And it's also part of the requirements and updates for the commit path too. So we have a place where we annotate like which version is being used or what's being submitted as a version. So if you commit to a table or try and create a table, you have which version you're trying to create that's already there. So this would be kind of duplicating that at a higher level from the server side, but you still run into the discontinuity of like, just because the server says I'm 2.0 doesn't mean that they fully support 2.0. So you still potentially could get rejected at the commit.
True.
It feels unnecessary.
On the other hand, I mean, the second vote that has passed was about fixing attribute names, which were inconsistent in the spec. And that went unnoticed, actually, because nothing is validating it on either side.
That's true, but
So
that
how
would be like, oh, go ahead, Ryan.
How would that have changed if we introduced an extra version here?
You could have said that, hey, I'm validating this doc and not just blindly ignoring attributes that I don't know about.
I don't think that. So if I were going to follow what you're saying, Robert, and I said, okay, well, what if we already had the versioning when this was introduced? That would be a tables version update because it affects the actual REST spec. It wouldn't be a table spec update.
You could have validated the incoming thing. I mean, assuming that the error happens somewhere else, but assuming that you get a field that you don't know about because it's not in the spec, the server could say, hey, your request is definitely not valid. But if you have the ability or the requirement that a server must not or must ignore fields that it doesn't know about, then strange things can happen. Up to the point where
it's a much more general problem than anything to do with how we tie the table spec and the REST spec together. The table.
I'm not saying we tie it together. I'm saying the server should say, I'm supporting this version of table spec, view spec, whatever.
If I may interject a little bit, I think the email discussion was at some point mentioning that the purpose of capabilities is to allow clients to be executing in a kind of more coherent way. So say if a client connects to a server and the server says I only support v1, but the client only supports v2, that's something that the client can detect right away and basically stop operating, right? Of course, if the server declares v2 but has a bug in its implementation, yeah, errors are possible. But I think the main purpose is just to have kind of like a brief startup kind of check. Or for example, if the server declares I don't do multi-table transactions, then the client obviously has to do each table change individually, right? So that's the kind of capability that the client can process in a intelligent way, right?
So can you clarify
the client,
what on the client side would be here then?
I'm sorry, I didn't catch that, Ryan.
So what decision on the client side are you proposing? Let's get.
I'm not proposing. I'm suggesting that if the server declared, sorry, I'm suggesting that if the server declared the table spec version that it supports, then the client could check whether it has an overlapping version support with server. So, for example, if the client is compiled to only operate on v2 format, and the server declares v2 and v3, then it's all good, right? So the client can submit its request. But if the server declares only v4, then the client can just warn the user or just refuse to start, something like that, right?
Can you be specific about a case where the client needs to act differently?
For example,
I'm not understanding and I'm asking Dimitri. I'm not understanding the use case here where the service and the client are mismatched in some way, where the client is ahead, but the client then downgrades what it does.
No. I mean, the client obviously could downgrade if it has the capability to downgrade, but I'm not trying to propose any particular way for clients to operate. What I'm saying is that, at least how I view the server capabilities in general, is that's a mechanism that allows the client and the server to kind of proactively avoid some really bizarre mistakes, right? And one of the cases which I envision could be possible is that if a client connects to a server that doesn't support the table version that the client is compiled with, then the client can use the capabilities and detect that upfront before it even tries to write any data to storage. Yeah, it should be more specific. Suppose the client, a very old client, is compiled to only write table v1 format, but the server does not support v1 anymore because it decided not to support it.
So we don't really have a case where the service can say, hey, I don't, right? The backward compatibility requirement in the table spec requires that the service always honor v1 metadata. So I don't think that that is a use case that we have. Now, I totally get the point that Russell is making, and I think one of the points that Robert made, which is that certain things you cannot ignore, right? Like if the service doesn't know what a requirement is, it needs to fail because that requirement is something that it can't satisfy. So if that's not explicit in the spec, I think it probably should be, and that's a good clarification to make. But I'm not seeing the value of declaring versions that are supported unless we can come up with a use case, right? I think that you were closest with your description of like a client that supports a future table version, a more recent table version than the service, but even then I'm not quite sure what would happen. The way I think about this versioning is that the REST protocol lags the table spec because you can't send things to a service that the table spec doesn't support, right? So there is this case where if you have a newer client and a very old service, right, we sort of assume that the service supports everything that the client supports. But then I think a lot of this is evolving the spec in a way that we don't add new fields to existing structures or things like that without, is this something where we can take care of it with the versioning of the REST protocol? And that's the question for me, right? Is this necessary or is this redundant because we can already take care of these issues if we're versioning the protocol correctly?
Yeah, if I might just add a little bit of notice. So say we already have tables as a capability. And now we're talking about declaring specific table specific spec versions. From my point of view, if we only declared spec versions, that already overtakes the table's capability, right? So say if the server declares I support table spec version 1 and 2, implicitly it supports tables, right? Then we don't need the tables, like the plain tables capability at all. So we can just use the capability that declares specific spec versions, right? So that already covers the tables capability use case, plus it adds a little bit more information that could be leveraged by clients for proactive compatibility validation.
I'm not sure that it works that way because the way that we version the table spec, you can add additional things as long as they are not breaking forward compatibility. So as long as you're adding things that are backward compatible, it's okay. For instance, you can write, say, statistics files or partition statistics files for V1 tables. So V1, as long as older clients can correctly read, we allow things that are newer. So I'm not sure that the table versioning works the way that you would want it to in that case.
Oh, I'm not talking about changes in a particular spec version. I'm talking about introducing a whole different, like V3, for example. Is V3 always supported by servers that support V2? I don't think so.
No, but the combination there of what the tables version is from the REST spec, plus the mechanism by which we do like the example that you were using before. Hey, what happens if a client creates a bunch of data and then goes to commit it and then finds out, hey, the version that I created, V3, wasn't supported by the service? Well, the mechanism by which the create table even works, you post that metadata at the beginning. So the catalog already has a chance to validate what the version is before you would do any of that work. The same is true for many of the other operations, and a lot of the table interaction is driven by what version is sent back when you load the table. So you shouldn't be taking a V2 table and then writing V3 metadata and then posting it as V3. You have to upgrade the table version. So a lot of this is like kind of inherently handled by the constructs that we already have in place. And we do need to keep these two things separate, where it's like we version what's happening in the REST API, and like a table bump could, like a table version or tables version bump in the capabilities could mean that, hey, you need to actually use a new endpoint or something like that because we've changed the representation of the request and response objects. But that's different from the actual table spec version, which is handled through the communication of those request and response objects. So I think what we're saying is like we don't see the use case right now that would actually require that. So I'm a little concerned about adding it because it's duplicating information that's in other places.
Yeah, that was basically what I was going to bring up as well. The table, if you have a table in the catalog and it's V3, you can only interact with it with V3. Like there's nothing about any APIs that the REST server can do that can change that. The client has to do V3, the catalog has to accept V3. And the only place where you get to choose that is in upgrading or in creating tables. So I think that'd be it.
I think there is a strange case here, here where we do allow adding structures as long as they're backward compatible with the table spec. So this is like the partition stats files is a great example. But the way that we did that is you have new objects or new metadata changes. So there are requirements and metadata updates, and anything new needs to go through the metadata update path. This is actually like I think that we would be. We actually have a really good example use case in the partition stats, as well as the encryption metadata that we're going to be adding. So maybe what we should do is just pause and think through the encryption cases, because that's going to make changes like this to the protocol. And I think it would be instructive for us to just see what we need to do in order to maintain compatibility there. Sorry for jumping in.
Yeah, sorry,
No worries.
Robert and JB.
Yeah, so I think a lot of confusion is happening because a lot of people assume that metadata is always persisted as an object, which is like fixed. But servers are not forced to do that, right? So a server can logically say, okay, this is a V1 table, but no, my client is using V1 anymore, so I'm suddenly upgrading them to V2. And similarly, it could say, okay, this is the client that supports only V2, and this is a client that only supports V4. So I'm transparently giving the client the stuff in the version that it needs. And then you might have a main formed version, but that doesn't necessarily be the version you're working with. So things become can become quite complex if you think further, especially with use cases that I think Amazon's proposed, like pushing more table metadata like manifest information or manifest list information down to REST server, and then things become quite more dynamic, and that's when versioning becomes even more important.
Yeah, if I may, I have a couple of comments. First, I think that it's great to keep the client as simple as possible. I mean, we should avoid to put too much logic in the client, like as an example, multiple table transaction. It should not be something that the client should deal with. I mean, he has to keep pretty simple. For me, the server capabilities is really something that when the client instantiate itself, it just should check is it supported, yes, no. And if it's not, then it stop and saying, okay, it doesn't work. The other metadata, like everything in the metadata, the JSON, whatever, that could be used by the client at runtime when needed. There are no need to have another capability to describe something, but we can already access through existing metadata. But that's just my 2 comments, if I may.
Yeah. Thanks for flagging this, JB, because I think when I say client, I might have been misunderstood, because when I mean client, I mean the combination of the actual REST client implementation that talks REST protocol to the server, plus some custom code that actually generates the tables, right? So I completely agree that the actual REST client should be as simple as possible, but the server capabilities that are surfaced through the REST client could be checked by custom code that the user writes, and that may be important.
So I think just based on what Ryan said about some of the other things that may, potentially evolve, and I'm not saying that I'm like completely opposed to having like table and view spec in here. I don't see how that is going to be used outside of where it's already, being passed between the client and the service. So Jack mentioned earlier, we should probably get a doc written up about this one, because I think we thought it was going to be a pretty simple change and it has gotten quite complicated through discussion. So maybe we should shelf this one, get info back to Edward about this, and then maybe if we can come up with some specific examples, whether it's with encryption or we have specific ones that we can see happening with the table spec, we enumerate those, and then we can kind of point to those as like why we introduced the table spec version or why we excluded it for now, because we can always add it later. It's not something that like we don't expect this to evolve as new capabilities are created. It's just a matter of like then we would tie it to a particular like tables implementation version.
I think Russell is right that we should consider how new types, default values, and things like that are affected by this. Like I really think that let's get concrete examples, because those are going to be the most instructive way for us to figure this out.
Okay, I think that's a good conclusion for us to move to the next topic. The next one seems like, okay, REST server implementation. I think this one has been brought up for quite a few times. I also brought up in, I think, one dev list discussion that I think it's becoming pretty difficult to validate server-client interactions without a reference implementation. I think there are a few other comments here in the community sync doc that there are people saying about integrating with Gravity. So sorry, I cannot pronounce this name. Gravitino, and maybe making that a sub project. I don't know what does it mean to mitigate the catalog war, but if anyone can provide more thoughts on that, would be great.
I have strong opinions. I'll kick us off. Since we started the project, I've been pretty pretty consistently saying that I think Iceberg is specifications and implementations of those specs, but does not provide services that need to be running 24/7 and monitored, and basically, like, I think there is a huge anti-pattern with Hive and Hive Metastore, and I do not support adding runtime components like a Metastore to the project. I don't think that it's a good idea. I think that another part of this is that we want a lot of different implementations, and there already are different implementations where I think, I've heard that Glue is working on it. I know Nessie is working on it. There's Gravitino. There is from Snowflake, the new one, what's it called? Polaris. I have a very hard time with the idea of choosing one of those implementations and bringing it into the project. Now, the points about how do we test, how do we make sure that there is something that you can work against, to me, that is the REST catalog client. We have a REST catalog service, or the catalog handlers, which, by the way, are used in some of these projects, that translate to the older catalog API. And I think that is working very well for internal testing. And like, I don't see the need for anything beyond that, especially given that there are a lot of implementations out there. So I'm again, like, fairly strongly against the idea of adding runtime and service components. I don't know who was next. I think maybe Dimitri.
Yes, thank you. Yeah, speaking of reference implementations, I kind of agree that Iceberg, being more kind of a library project, probably does not need to provide a reference implementation that could be used, right? But I think it is important that Iceberg provides tests. I think JB mentioned TCKs in the email discussion about REST spec v2. I think this is critical, so to actually ensure that whoever comes up with the server side can run those TCKs and validate that it meets all the expectations. Right now, defining those TCKs in Iceberg necessarily requires to have some sort of CI, at least CI time server side, right? Which doesn't have to be production ready, just be functional enough to TCKs become the defining factor, and then they have to just run against some backend in CI and be validated against the spec manually and against that reference, not reference, but kind of like test implementation during CI. Go ahead. Who's next?
I think I'm next. First, I agree with Brian. I think that Iceberg is a table format, and it should be the table format. That's the first thing. The second thing is, as the spec is part of Iceberg, it makes sense to have at least the TCK, whatever the name we give, to verify that the spec is okay. And the purpose of the TCK is to prove that actually the spec can be implemented. That's the first reason of the TCK. And also, I agree that Iceberg should not have runtime kind of component. So maybe on a separate track, but we already have a Kafka Connect, which is also a runtime component partly. So maybe it makes sense to move this component in another repo, just to keep the core repo as the table format. But that's another discussion that we can have. So my point is, totally agree that it doesn't make sense to have runtime kind of implementation in Iceberg. It's not the purpose of a project, to my understanding. You guys have a better history than I. But also having at least a TCK or a small implementation or whatever, just to verify the spec, could be helpful.
I think JP was next.
Thank you. Yeah, I don't have a strong opinion if Iceberg community want to maintain a REST catalog. services. It depends on our community of Iceberg. But as one of the co-part of the Graphitino, I just want to, provide my opinion that the community may need a consolidated resource or some efforts on different, catalogs so far, because we all know that the spec is keep improving, from 1.3 to 1.4 to 1.5, and it sounds like a never-end game. But for if each or the REST catalog implementation, everyone has to do, a duplicated work. It doesn't make sense. I mean, that's one of the reasons why the Graphitino is a generic catalog service. We want to support the Iceberg REST catalog and want to lower or reduce, everyone's redundant work. I think that's the original thinking about it. So this is maybe an invitation or maybe a call for help. If Iceberg community doesn't want to maintain a service, and welcome to the Graphitino to, keep the things think up there, make it improve. I mean, as an open source contributor, people doesn't want Iceberg as a library only, but maybe a REST catalog service. This is my opinion. Thank you.
I think Dan was next. You're muted.
Yeah, you're muted then.
Sorry, I clicked the raise hand button instead. So I would agree with most people that have been saying, keeping the specification separate from the implementation, especially when it comes to the runtime systems. JB, you mentioned like the Kafka Connect. I think that actually kind of falls into the same category as like the integrations of, Flink and Spark and things like that, where it's Kafka Connected. The framework is Kafka Connect. The implementation of just the sync is what we're maintaining. And that's largely to keep those things moving along with the formats. There are other places where communities have adopted Iceberg support and they're maintaining it. So I think there's reasonable ways to have implementation of the library component in Iceberg, but it's also open for other people to implement the spec themselves. I think I would agree with what Ryan said. Like when it comes to the REST specification, we don't want to pick a winner in this space. And I think that that's kind of the challenge by picking one and saying, hey, this is the canonical like implementation, or this is the reference implementation. It kind of gives the impression that the project is supporting one in lieu of all of the other variations that exist out there. And we're seeing an increasing number of them. So I strongly believe that we want to define that specification, and that ultimately gets us to the point where we have broader reach and more interoperability, as opposed to like trying to pick one and saying everybody needs to use that. I think it's Jack.
I think Robert is before me.
Yeah, I just wanted to say, I think Dan mentioned it already, like REST implementations are not like one thing copies what the other thing does. It's a lot of very specifics come into play here, and things are implemented differently, and putting that in a generic implementation could be very elaborate generic implementation.
So before I make my comments, I just want to first have my AWS hat on. I don't think Glue is officially saying they're going to support Iceberg REST catalog yet. I think they are still making some decisions. But I think what we know is we do want to connect to Iceberg REST catalogs. That's why I'm here, and I think some other AWS people are here, because we want to make sure that things are at least properly versioned, so everything is stable before we connect to that. And with that being said, my original reason, my main reason for supporting reference implementation is mainly for compatibility testing. So if that is the direction you want to go, definitely +1 for that. Regarding what Ryan you said about using catalog handler, I remember we had actually a previous devlist discussion about that many months back, and I think we agreed that there could be a test module that has a whatever HTTP server that is serving requests and forward back to using catalog handlers and be backed by whatever.
We already have that in testing.
Yeah, we already have that. But I don't think we are leveraging that for compatibility testing right now. So maybe that's the next step.
Well, so I think we do want to have, like the shape of a TCK is, yeah, something to definitely discuss. We could do it better. We do try to run through the same catalog tests on all catalog implementations. Sorry, Alex.
Yeah, sorry. So I wanted to mention something that happened lately, and I think it's a good case for reference implementation as well. So basically, we have a very good test coverage so far, but almost everything is unit tests, right? That rely heavily on Mockito. So basically, we are creating a sandbox that mimics a perfect world where the REST server behaves exactly how we want it to behave. And so lately, I fixed a small bug that happened in the REST client that wasn't caught by the unit test because the REST adapter was mirroring the same error on both sides. So that makes it difficult to spot those kind of things.
Mm-hmm. Dan, you're muted.
I keep hitting that hand button. So I just wanted to follow up on the TCK thing, because I think that there's general support for TCK. I haven't actually heard anybody saying, "Hey, no TCK." So I guess the question is, like, right now we have catalog handlers in the Java implementation, and we're doing other tests in other places. So I guess the question is, is the path forward for a TCK taking catalog handlers and then making it available to all of the various projects as kind of the test base? So we don't necessarily need to do like deep mocking or something like that, but we're actually relying on, kind of that proxy behavior of like an image or something that we can use across all of those tests. Like, do we have thoughts? Fako, you're probably the best to talk about that and what might work for the other projects.
Yeah, so for both for Iceberg and also Rust, we actually use like this. I think you built it then for some history. It's like a REST catalog that's backed by a SQL catalog, and it actually acts like as a memory catalog. I think it's a bit of a slippery slope because people also are trying to use it in production, but it actually works quite well for testing the Iceberg and the Rust implementation. And because it will
we had talked about moving that into the test modules, so we probably want to make sure that that's all there. But that's what's being used by like the Rust project and the Python project for REST testing. Okay.
Yeah, that works pretty well. So it actually uncovers quite a few bugs like these inconsistencies, because I used generated objects that come from the Open API, and then if there's a mismatch, I can see it directly. For example, I didn't caught like the bug that been raised by Eduard because we don't implement like the partition level statistics yet. But yeah, I think it's a very effective way to test. It's very gives you a fast iteration, and it both helps you to find bugs in reference implementation as in the language that you're trying to and the client that you're trying to build. I would be much in favor of just making that public available. Yeah.
I can work with you, Faka. I want to take a look at how Python is using it, but we can introduce that and make sure that like everything's within like the test modules for this, and we can, then just build on that for whatever the TCK looks like. And I think to the earlier questions about, having like a reference implementation versus a TCK, like keeping it in the test modules keeps it out of the, hey, can we just run this thing in production because it kind of looks like something that we could run. And if people want to do that, we can't stop them. But I think it's more clear that like, hey, this is for testing purposes and compatibility, as opposed to we're like trying to build a runtime service for everyone.
I think one also the purpose of a TCK is also, as we have multiple implementation of catalog service, we should provide something that they can run on their own using mock endpoints or whatever, where they can have some assertion just to verify that these assertions are satisfied on top of what we implemented. So my point is what we did and focused on Python or Rust is great. And it's a good start to just package something that we can provide as a TCK. So if you take a look on Tomcat, for instance, we use Tomcat TCK, where you can verify that the JSP extra are well implemented and are running fine. So my point is, I think we have a lot of resources already there. Maybe just kind of documentation repackaging, just to be able to use on Gravitino, Polaris, whatever, just to verify that the implementation is okay on regard of the spec.
Robert?
Yeah, I think actually there should be two TCKs. I mean, one for a REST server and one for all the clients that exist. I mean, both have very different requirements when it comes down to compatibility testing. And yeah, I think those are two different things.
Yeah, I was talking about the server side implementation TCK. Well, that's true.
Yeah.
Correct.
Yeah, and both actually probably need an object store or various object stores, and yeah, the test matrix there can explode pretty quickly. Could, at least.
Yeah. Good point about client-side TCKs as well, because I noticed that in the Java REST client implementation, there is some reliance on Java exception class names, for example, which obviously doesn't map to Python or Rust. So, I mean, implementations can probably tweak it to be compatible, but we need to formalize it somehow in a TCK that whoever is accessing, like whoever is getting an error from a server formatted in a particular way, can operate on it the same way regardless of the language.
Yeah, I think you're talking about the use of no such table or no such namespace to clarify 404s in some cases.
Yeah, these two come up immediately, but I'm not sure if there are others, but those for sure.
Robert?
Yeah, just as a general note, I think we should stay away and put any language-specific name into a specification at all, because that, I mean, Java class name don't work in Python, like, naturally.
Yeah, we've actually been looking at that with a lot of the table properties and configuration properties, standardizing on things like, S3 as opposed to S3 file IO, or, passing in a class name. So anywhere where we see that, whether it's table properties or specifically anything that goes through the REST API, ideally we would avoid any language specific references. So just something for everyone to just be kind of generally aware of, because we ran into that a fair number of times in the early days of Python, and we started kind of massaging things a little bit. Like even the catalog implementations, types, things like that, we favor using like REST over like the fully qualified REST catalog.
Okay, I think we can move to the next topic, which is standardized namespace behavior. I think this is about different catalogs have different behaviors for handling nested namespaces. Anyone has any comments about this?
So I can speak to this. Catalogs tend to be opinionated about this. So the idea was, first of all, we have catalogs that do support multi-level namespaces, catalogs that don't support multi-level namespaces, catalogs that can just create namespaces if there are objects in them, other catalogs that don't, and things like that. So the original spec was written to allow catalogs to be opinionated and not require specific behaviors here. I'm totally fine revisiting that and figuring out, is that a choice that we want to continue with? But I just want to point out that the original intent of this API was to allow people to, do different things at this level and sort of let them determine the user behavior and how it appears.
So I would say that I probably lean more towards allowing catalogs to define their behavior. And if we aren't going to do that, then I would probably do, I believe what is the opposite of what is suggested in the actual email thread is we take the most strict approach, which would be closest to what you would expect SQL behavior to be in relational databases, where I can't create a namespace by just simply creating a table under something that doesn't exist. So if I remember correctly, the thread was like, hey, let's allow that kind of behavior or standardize that. And this is where, yeah, some of the implementations that we have out there, they don't even really know about namespaces. So having something in a namespace is kind of like, it's kind of like S3 with directory pathing kind of thinking. Like you have something there and it creates the directory paths. I would lean towards either allow catalogs to still kind of like implement and throw errors as they should, because like if a 404 comes back with create table for a namespace, a client should be reasonably able to handle that, or at least confer that information to whoever was issuing the command. And if not that, take the most strict interpretation, because if something is more lenient, you're probably not going to run into problems. But if something is strict and you're trying to define a behavior that it can't support, now they just can't support the REST spec.
Just one thing, Dan, I want your perspective on that. I mean, namespace is not part of the spec today. I mean, every implementation decides the way they want to deal with namespace. But it seems that, as far as I remember in this thread on the main list, the discussion was JDBC catalog manage the namespace like this, and NICI manage the namespace like this. Do we have to, at project level in Iceberg, do we have to announce the default behavior for namespace, or do you think that it's still valid that each implementation decide of the namespace they want to deal with? I'm a little bit confused by that.
So my position would be allow them to use the error codes to define their behavior. So if you try and create a table and there isn't a namespace, the catalog can choose to say, I'm going to just go ahead and create it dynamically and not throw an error. I'll do what you asked me to do and create the table under that location. Or it could say, I'm a more strict implementation. You have to create the namespace first. I'm going to throw a 404 for that namespace, and then the client has to go and issue the other command. And either one of those, like, you're getting proper feedback. We could be really strict and say, no, like, you have to, throw the error for the namespace. But then it's like, if somebody doesn't support that and they create it dynamically, well, you don't get an error and you get the behavior you want, but they're technically not in line with the actual catalog specification at that point. So it's one of these areas where I don't feel like we have to take a strong opinion about it, and things will generally be okay.
Yeah, I agree, but I don't think that it makes sense to be strict. My only thing is maybe it would make sense to have a capability to inform the client or the user how the REST catalog server implementation behave in advance, just to avoid to be surprised. I don't see necessarily a capability, but at least a documentation. Like, be careful in my implementation, I'm dealing with namespace like this.
Mm-hmm. Yeah, I could imagine anybody implementing it, like, they should document that. But do we need to formalize that? And there may be cases where, like, it is really important a client would behave completely differently. So I agree that, like, hey, you could do something different. I'm just, is it really going to make any significant difference? Like, there's a lot of systems out there, and I don't think any clients right now that I know of, like, treat different databases differently when they interact with them. You rely on kind of the errors and the feedback to go and make those changes. So I'm open to it if we can find really good use cases. It's just
no, but that's all right. Just wondering. I mean, I remember when I implemented the view support in JDBC catalog, we deal with namespace, and we have in the test something like a test namespace create is required, is a flag that we put in the abstract class that we implement. So I'm just wondering if it makes sense. I mean, we can ask to be implementation, or they can do them themselves, like adding how they deal with namespace just for clarity and to avoid to confuse users. So yeah, that makes sense. Thanks.
Oh, I think I'm next. So yeah, I think to what's I think also being discussed on the chat a little bit, I've noticed that it's at least helpful that in the tests, like in the unit tests, there's at least some degree of formalization of different categories of behaviors. So when people are trying to reason about an implementation, it's helpful at least, right, that you can, like somebody who has the unit test running against this implementation will say in the unit test that support requires namespace create, or supports parent names, or supports nested namespaces, etc. Right? And I think in this vein, it seems like there are at least a couple common patterns that emerge that sort of de facto start having some standardization around them based on how the test cases kind of work. One other thing I noticed though is that, like, in some cases there's also a lack of internal consistency that might be worth choosing one way or the other. Like in the JDBC catalog, for example, if you do explicitly create a namespace and then create a table underneath it, that namespace sticks around after you've deleted the table. But if you let it do an implicit namespace by just creating the table, then the namespace now can disappear when you delete the table. And I think like that kind of internal inconsistency is something that could be worth actually fleshing out. And I think I think to JB's point about some lack of spec around namespaces, I think I've at least noticed this is just like when looking up, what, even if it's just for comparative behavior, not looking for like a formal requirement, but just comparison of things, there is a noticeable lack of documented preferences around how namespaces should behave. And I think it is worthwhile, I think, to at least sort of call out like the main things to think about, right? Like one example is, suppose you do want some kind of object stored path inheritance behavior. I know it's like some of these implementations have like a default location sort of embedded as a property in the namespace. And then in those cases, you would need an object to represent your namespace and so on. But yeah, so just starting some de facto standardization around things.
I think that that's a good one to think through. Like if there are reasonable behaviors that we can specify as sets of things, then that sounds good. Again, like if you have like a Hadoop catalog type setup, and granted, we can and should discourage Hadoop catalogs, but if you are representing, which I think this is what Microsoft does, representing your namespaces as paths in a file system. Can we ask that if you create a table that the namespace persists after you drop the table, or things like that? I don't really know. That was one of the reasons to leave this pretty flexible. There are lots of different ways of representing that data in the back end. And I don't think there's a ton of value in being real descriptive here. This is definitely an area where catalogs should be descriptive about what their behavior is. But I don't know that there's value in actually requiring certain behaviors for the API. I think it's very nice whenever an API or a spec can leave things to the implementation to have that flexibility to decide.
Yeah, and I think to that point, I'm more advocating for like having the vernacular to describe your behavior, kind of like how HCFS, Hadoop compatibility tests end up going about it without being prescriptive, but at least having like a common vernacular to describe your own implementation.
Yeah, so I do think that being able to test optional features, or at least the way that a service behaves when a feature is optional, is necessary to ensure that that the service and the client are going to work together, right? Like, so we were talking earlier about if the service itself does not support implicitly creating namespaces, then it's going to return a certain error, and then the client is going to react a certain way, and things are going to be hunky-dory. But if the service itself does not behave in the expected way when it doesn't support a certain feature, right? Like, then the client is not going to be able to handle that case. And so this is where I think that the idea that the TCK being able to support testing even optional features and behaving a certain way when a service does not support an optional feature is necessary to ensure that clients remain compatible, even with the service that's not implementing those features.
I'm not sure that I agree with that, because I can express a lot of different actions, and we can agree on how to express an action, whether or not we agree on the situations in which that action is valid. So, like, for example, if I create a table and then drop that table, is a drop namespace going to say, yes, I deleted that namespace, or no, I did not? Right? Like, I can express all of those things, and we can agree on how to send those requests to the service, but we don't need to necessarily agree on whether that namespace still exists after I've dropped the table. So, like, yes, there are some things where we want compatibility tests to make sure that we can all speak the same language, but that it doesn't mean that we have to have identical behavior in order to do that. I think there are some areas, right? Like, after a create table succeeds, a table exists should say yes. But we don't necessarily want that everywhere across the board, to define those specific behaviors, because then we're actually getting into a set of things that I'm at least not confident all catalogs can deliver.
I think that makes sense. I just keep thinking about how S3 does this in the Hadoop AWS module, where because there's no proper directories, it's got the special like handling for putting in flags and stuff, and that's just not great. So if we have a standard, let's have it so that we can avoid those situations.
Things can become very complicated if you consider access control enforcement. You could perfectly say, okay, I'm creating table foo.bar and assume, hey, the catalog does implicitly create foo, but foo might be a namespace that you don't have access to, right? Similarly, if you have a nested namespace and you drop that only table you see, should you expect the namespace to disappear? There could be another table that you don't see. So things become very, very difficult with these things.
I think we have consensus here that this is something we should describe different behaviors that we expect the catalog might be able to take, and make sure that implementers write down specifically how they expect it to behave, but not test them.
You can't test. You can't really test them. You can allegedly expect that an error happens, but it could be an access denied. It could be a generic error because the implementation decides not to tell you that some other table is there. I think the amount of things that how a catalog could react, it's just endless. I think you can't test it. You can't, at least you can't explicitly formalize it in a spec or in a TCK.
the other thing, I completely agree with you on access controls. That adds another dimension, and that's another area where like we don't, we know that there are multiple models out there that don't agree, like how access controls cascade from the namespace level to the other levels, to the table level, and defining all of that behavior, and then saying like, implicitly created things, whether or not they have to, like, yeah, that's kind of a mess when you start layering those together. Sorry, Dimitri, go ahead.
Yeah, but at the same time, we can probably configure TCKs with server capabilities. For example, if the server knows it wants to throw missing namespace exceptions, then it could flag something and let TCKs validate that. Right? So TCKs would expect that kind of error.
I mean, maybe you need to have.
Just to clarify, the purpose of that would be to ensure that all servers, for example, that flag missing namespaces will do it in the same way. And we could also, go ahead, Robert.
Sorry, no, you speak.
And this way, TCKs can also ensure that the namespace does not exist there is actually getting the same type code, whether it is coming from get namespace or from get properties or from just creating a table in a missing namespace, right?
I think the main thing is we need to be careful that we're not over specifying this, because if this is an area where there are very, very few downsides to a catalog implementing something that they think makes sense, and like it doesn't necessarily have to fit a pattern. If there are only so many patterns that make sense, calling them out and testing one of those patterns is great, but I'm not sure that that's the case, and I would hate to have a whole bunch of things failing after an implementation makes reasonable choices, just because we've over specified things that we did not need to. Specifications, I think, a very important part of a specification is all the stuff that doesn't go in. All the stuff that you can change or modify on the back end, right? I think we appreciate this in the table spec a whole lot more, where, the table spec doesn't tell you how to move from one table state to another. It just says you can, right? Like these are valid table states, and whatever you want to do to move between them is up to you. I think that sort of thing is important across the board, so that people can have different implementations, make good choices for their things. Anyway,
I think
it's way past time, so I am also going to drop. So thanks, guys. Bye.
Just wanted to add, like that spec and TCK are two distinct things. The TCK must assert very thoroughly on a specification, but an implementation can come along and say, hey, your TCK is validating this, although it's not in the spec. Can we please fix that, or add a flag to the TCK?
Cool, sounds good. I think we are over time, and I would encourage people to respond to the dev list for all the points we have discussed so far. And there are also a few other dev list discussions that people can participate in. So thanks, everyone.
Bye, all.
Thank you. Bye-bye.
Thanks.
Bye-bye.